Apurva, Jayshree, Prashant, you are able to see the content.
Yes, ma'am.
Okay, ma. Thank you. So now today we'll discuss about the smart city security architecture, right? So the most of the smart cities and the citizens who are living in that smart city. One second. Most of the smart cities and the citizens in the data security, they have vast sensitive information and are being shared with all the cities in the layer. And there will be a cities which is protect their citizen data from unauthorized access, collection and tampering of the data. Okay. In general, the citizens of that country will feel better about data security when the city itself are not a private entry owned public or city relevant data. Okay, it is up to the city and the officials who run it to determine, like municipal corporations, right? And BBMPs, they are going to determine how to utilize the data which is produced in the street layer, right? When a private entry owns city relevant data, the scope of the ownership may be initially very clear. However, there are some considerations to change in the private entity strategy may shift the way the data it is going to be used in the whatever the data we have accessed, how we are going to use that data. It may then be way more difficult for city authorities or the citizens to oppose this new direction simply because they do not have any stake in the decision making process of the private entity. In addition, private entities may have financial interest and political motivations, okay, and they may not have the security standard or the accountability matrix city governments commonly possess or acquire through public votes. Okay, for example, suppose that a private contractor is in charge of the collecting and managing the parking sensor data. One of the possible way to increase the profitability of such data is to sell it to insurance companies looking to change an additional premium to car owners parking in the street, okay, covered and secured garage. Okay, such deviations from the original are likely to happen when cities own the data and when citizens have a way to vote against such usages. Okay, there are some network deployments use as soiled approach and do not always follow open security standards. Agencies may run applications and servers on the public cloud and have limited security safeguard implementations. And these network deployments use a soiled approach and do not allow follow open security standards. So agencies may run applications and servers on the public cloud where there is a limited security safeguard implemented and use of cloud-based collaboration tools without proper security, right? Hence, there is a need for a centralized cloud-based compliance-based security. One second. Okay. And there will be a need for cloud-based, compliance-based security mechanism to address and the needs of the service providers and end users. Security is obviously an end-to-end problem, starting with where and how data is collected, and it has been condensed and filtered the data and throughout the entire data processing cycles, right? So that is done in the data center layer, right? Okay. So a security architecture for smart cities must utilize security protocols to fortify each layer of the architecture and protect city data. Okay. So the reference of architecture with specific security elements highlighted. Security protocol should authenticate the various components and give the protection for the what is the data which is transporting throughout the network. Okay. And if you take a hijacking traffic sensor to send false traffic data to the system, regulating the street lights may result in the dramatic congestion issues. The benefit for the offender may be ability to get all greens while traveling, but the overall result would typically be dangerous and detrimental to the city. The security architecture should be able to evolve with the latest technology and incorporate regional guidelines. For example, city bylaws, country or regional security regulation. Network partners may also have their own compliance standard security policies and government governance requirements that need to be added to the local city requirements. Come to the smart city, how it is going to be connected in the city reference architecture. Just see here how it has a key smart and connected city reference architecture, how your street layer info, what are the devices they are going to evaluate the information, how that information has been transported to the next level of the layer, that is city layer, and from there with the switches, routers and gateways, how the data is going to be transported to the data center layer. From their data center, how the data aggregation takes place, and how the data is going to be filtered and condensed, and it is going to be transported to the service layer where the users are going to use that data. And here the end users or the end devices. Okay. From the service layer they are going to get the data from the place of the service layer. That is why that name itself says that the service layer, which is going to provide the data to the end user, service to the people or to the end devices. Okay. Starting from the street level, sensors should have their own security protocols. Some industry standard security features which are going to include device sensor identification and authorization, device sensor data encryption, trusted platform module, which enables self-destruction when the sensor is physically handled, and user ID authentication and authorization. Sensor identification and authorization typically requires a pre-installed factory, that is a X.509 certificate and public key infrastructure, what we have studied in the cryptography, that is a network security tools at the organization level. Okay, public key infrastructure is at the organization level, where a new certificate is installed through the zero touch deployment process, and this additional processing may slow the deployment but ensure the security of the exchanges. So we have come across the cryptography, that is a computer network security tools, where we are going to give much importance for the security of the data which is flowing in and around distributed in the network. Another consideration may be type of the data that a sensor is able to collect and process. For example, if you take a roadside car counter may include a Bluetooth sensor that uniquely identifies each driver or a pedestrian. Okay, pedestrian. Security consideration should determine whether this information should even be collected or not. If it is collected, it is going to be based on the decision should be made whether this data is going to be processed using the online process or not, in which information is used for analytics. But individual identifying the data is not stored and is therefore forgotten immediately, or more classical analytical process in which data is stored temporarily, either because the algorithm needs to avoid the duplicates or because trajectory determination is part of the data processing. Data should be secured at rest and in motion. As I told in the previous section that what is data at motion and data is at rest, right? The data which is moving in the network, it is called as a data in motion, right? And the data which is stored in secondary storage devices and kept in the shelf for the future use, that is called as a data at rest. Okay, but when the data is stored, additional security is going to be needed to put in the place to ensure that information will not be tampered with, abused or stolen. This is true regardless of the location where the data is going to be stored, whether the data is in the cloud or data is in the edge computing or it is in the fog, okay, or that is a gateways. Okay, the city layer transports data between the state layer and the data center layer. Okay, it acts as a network layer because it is transporting the data from the producer to the consumer. So we is as a consumer, data center layer is a consumer at present. Why? Because whatever the data is produced in the street layer, that has been transported to the data center layer for the condensation, filtering and aggregating the data, right? That's why at present we call that as a the consumer, and this is a network layer. It acts as a network layer to distribute the data, okay, to transport the data. Okay, so now what happens is whatever the data, when it is going to the common industry elements for security network layer is there will be a firewall and there will be a VLN encryption. Okay, so these are all the security tools for the on the network layer. So what is the job of the firewall? Firewall is located at the edge and it should be IPsec or VPN ready and include user and role based access control. You should also be integrated with architecture to give city operators remote access to the city data center. Okay, so we LAN, that is a provides a end-to-end segmentation of the data transmission, further protecting the data from rogue intervention. Each service or domain has dedicated VLN for data transmission. So protecting the traffic from the sensor to the application is a common requirement to avoid the data tampering and the eavesdropping. In most cases, encryption always starts at the sensor level. Okay. So in some cases, the sensor to gateways link uses one type of encryption. Encryption, it is going to be protecting the traffic from the sensor to the application is common requirement to avoid the data tampering, and in most of the cases encryption starts at the sensor level where the data is going to be produced by the producers. In some cases the sensor to gateway link uses one type of encryption and the gateway to application connection uses another encryption, for example a VPN. Multiple specific elements such as switch-to-switch encryption may be required by each deployed IoT solution to increase the reliability of the system. Because when you are going to do the switch-to-switch encryption, right? So there will be no loss of the data and you are providing the more security for the data during that switch-to-switch encryption, right? At the data center layer having secure virtual private clouds, a common requirement is that we have to create the dynamic perimeters around application, clients, host and shared resources can further obfuscate the data from prying eyes, right? Integrating the latest technology frameworks such as mutual transport layer security, that is MTLS, on Ortho 2.0 for device attestation, and identity based access is a key to ensuring the integrity of the city solution. These are the two latest technologies where we are working on it. That is the integrating the both the technologies, so that we can identify the what kind of access is going to be provided for the citizens, that is going to ensure that the what is the problem in the city and how it can be solved. See, okay, why we say that MTLS is the more advantageous means because it is bidirectional and it is going to work both on the clients and server. Identities are ascertained during the authentication phase. This bidirectionality presents the advantage of preventing unauthorized clients from accessing the network and also increases the system flexibility by allowing each side to act as a client or server. For example, a sensor may be a client in connection with the cloud applications, but it may be a server for the gateway or the other sensor, where this gateway is going to act as an intermediate for the client and for the gateways. Okay, for as a server for the gateways and as a client for the server. Okay, that is how we can say that is it is going to act in two places. And one more latest technology, that is OAuthor. It is an authorization framework that enables application to obtain a limited and control access to the target services like HTTPS. Okay, if we are going to give this website address, right, we can learn lot of things, information on the authorization framework of this OAuthor. Okay, now and these are the prioritizing security logic in layered architecture. They are going to reduce the chances of serious network security breach or privacy violation of the city data. Smart city use case examples. We'll take some of the examples how we are going to make the city architecture smart as a smart city by having the multiple ways we can improve the city, can improve its efficiency and the lives of its citizens. Okay, and we'll take how we can make different areas of the smart city as the smart city architecture. We'll take some of the examples which is going to illustrate the smart city. Okay, we'll take some of the implement IoT smart cities, that is a connected street lighting, smart parking system, smart traffic control and connected environment, and smart hospital management, right, and home energy automation, right, and the factory logistics management, smart logistics management for some of the companies who are having the some of the sensor devices connected to that particular factory. Okay, while each of these solutions could fill in the sake of the brevity, we keep this discussion as a high level and tied to the conceptual architecture. Additionally, we have the transportation topic that also apply to smart cities. In addition, we encourage to refer to the rest of the to get more in-depth information about the smart objects at various layers and also about the general architectures and protocols required to support these use cases. Other vertical specific industry also provide valuable information about their applications that are implemented at the city level. And see, we will take one by one use cases. You take as connected street lighting. Of all urban utilities, right, street lighting compromises one of the largest expenses in municipality, that too especially in the metropolitan cities, right, where the power utilization will be more, okay, because so many malls will be there. Hmm? And almost it is a distance of about 50 kilometers distance the city has been enlarged, utility bill accounting up to 40% of the total. According to the New York State Department of Environmental Conservation, maintenance of the street lights is an operational challenge given the large number of lights and their vast geographic distribution. Okay, so connected street lighting solution. Cities commonly look for solutions to help reduce the lighting expenses. At the same time, they want to improve the operating efficiencies while minimizing the upfront investment. The installation of the smart street lighting solution can provide significant energy saving and can also be leveraged to provide additional services. In this regard, so we have the LEDs, that is the light emitting diode technologies, lead to the transition from traditional street light to the smart street lighting. How means? So we'll learn how these LEDs are going to help the traditional smart lighting system to the smart traditional lighting system to the smart street lighting system. So LEDs requires less energy, as we people know that, right, to produce more light than legacy lights, and they have much longer lifespan and longer maintenance cycle. A leading lighting company estimates that complete switch to LED technology can reduce individual light bills by up to 70%. LEDs are well suited to smart solutions use cases. For example, LED color or light intensity can adapt to site requirements. For example, warmer color and lower intensity in city centers, sunlight clarity or highways, time and weather, adaptive intensity and color. See now, you can see the graph. So electricity prices by country, world market. Now, so this is a different countries, how much the cost they are going to impart on the, especially for electricity, right? So LED lamp unit sales and LED lamp cost per unit. You just see this. Okay, how drastically they decrease in the lamp cost per unit when we are going to start using the LED technology, right? So Energy Information Agency, this is a data which is taken from the International Energy Agency. Okay, see electricity cost versus LED cost and sales. The global transition to LED is a key enabler for smart cities to begin the moving toward ICT connectivity solutions. As electricity bill rise and prices for LEDs drop, this hardware transition can open the door to complete the smart lighting solution. A comprehensive smart lighting solution enables the converged networked system that incorporate LEDs based fixtures and dynamic lighting control, which is supported by the layered smart city architecture, which is going to be easily extensible to support other use cases and solutions to benefit the city. Okay. We'll come to the how the architecture is built in street lighting architecture, how it has been built. Even okay, we start using the LEDs and how it has been implemented in the architecture of your street light. Okay, so we'll consider this one. So take the example of the street lighting architecture. Connecting the connected lighting uses a light management application to manage the street light remotely by connecting the smart city infrastructure. This application attaches to LED lights, monitors their management and maintenance, and allows you to view the operational status of each light. In most of cases, a sensor gateway acts as an intermediate system between the application and the lights. That is a light control nodes. The gateway relays instructions from the application to the lights and stores the local lights events for the application's consumption. The controller and LED lights uses a cloud to connect to the smart cities infrastructure. See now how your connected lighting architecture will be. Okay, this is taken from the source Cisco Smart Plus Connected Lighting. See here. So device management cloud will be there where we are going to send and receive the information from the cloud layer, right? And see light control node which is going to be connected to the Wi-Fi RF mesh. And there are some sensor gateways and switches, gateways and routers where light actuation and events are going to be sent to the device management cloud. In turn, the device management cloud will send the information to the cloud layer, and from the cloud the operators or the light management application is going to use, or the mobile application, that is a source application, also can access the data which is stored in the cloud layer. Okay, a human or automated operator can use a cloud application to perform a automated scheduling for lights and even get light sensors to perform automated dimming and brightening as needed. The schedule can also impact the light intensity level, and possibly the color depends on the environmental condition, whether time of the year, time of the day, location within the city, and so on it all. Whenever we are going to collect some whenever we are going to collect some of the place color of the LED or light, it depends upon the location, right? It depends upon the whether you are doing the in the night or in the day. Okay, at what time you are going to do that work, and location within a city, which area, and what is the condition of that weather condition of that city, right? Everything is going to be countable because the light management system is having the dimming or brightening is needed. Okay, so the lights and even the get light sensor to perform a automated dimming and or brightening is needed depends upon the area of weather conditions of that particular city. Okay, so when you go for, say for example, in rainy areas, that means all throughout the year there is a rain in a particular area in the parts of the India, right? So their light is very much needed, brightening light is very much needed for that area. So that is why light management role is very very important. That is time of the year, either in a rainy season or cloudy season, that is a summer season or a winter season, right? And location is in the city, right? It all depends on the environmental conditions also. Okay, so lightning nodes vary widely in the industry, especially with respect to element like what communication protocols they use. For example, Wi-Fi, cellular, Zigbee, 802.15.4G or low area wireless area network. Level of this is based on the sensor capability. These features are optimized for different circumstances and conditions. No single lighting node can support all environment ideally. Yes, it's very true that. So no lighting is going to support a particular area or day or the weather conditions of the environment, right? So for example, if you take a city centers may be locations where Wi-Fi easy to deploy due to proximity or the Ethernet or internet backbones ranges on the order of 100 meters high urban furniture density offering the large choices of relays and gateways. Whereas highways may mandate longer range solutions like cellular or low area networks, many solutions leverage wired connectivity either by using the existing city cable infrastructure or they're going to add cable adjacent to the power cable. In case where cabling is not practical, so we are going to use a wireless technologies that may be bring interesting capabilities. For example, if you take 802.154G controllers, they can be used to form a mesh and extend the network. This extension is used not only to connect other lights poles but also to connect the smart meters from neighboring houses. In all cases, the built-in versatility is offered to the four-layered architecture. It is going to ensure that all the different types of technology optimized fit any city topology can be flexibly incorporated into the solutions. One second, I am there in the line. So we are taking a smart lighting system. So where it is going to ICT connectivity solution, it is going to utilize the existing asset of a power source, enabling the asset to ICT technology not only drives the revenue on its own, but can also drive solution by being asset for different technologies pieces used to operate. For example, if you take LED lights, bulbs are commonly equipped with basic sensors and can detect a light. Okay, and that also can detect many other environment parameters such as temperature, motion, pressure or humidity. Adding such functions to sensor typically adds only marginal cost. Only a reasonable cost we can run the show. Okay, the great advantage is that street light can also become local weather reporting stations. This information is useful for local citizens and also for a city weather reporting stations, transportation system that need to detect real-time driving conditions. Functions such as monitoring power, measuring the oxygen and carbon dioxide levels, they're measuring the amount of pollution or particulate the matter and detecting the levels of long wave ultraviolet. Ultraviolet or short wave ultraviolet radiation can also be added to provide additional values to the services. So if you take for example, pollution monitoring, pollen alerts, energy grid monitoring, more specialized capability can also be embedded, such as basic audio or video functionality with filtering and analytics to detect the traffic congestion or the car crashes. So efficiency is going to play a very important role in in smart cities, which is going to including the connected lighting. For example, the amount of lighting can be reduced on highways where no cars are detected. Lights can be set to blink with a specific pattern to help a police to locate a specific GPS location as early as possible. So using the IoT for lighting allows for a useful applications, and for this reason lighting is often used an important introductory IoT function for smart city deployments. Municipalities often start with energy cost saving as a primary priority and soon realize that sensor added to the already deployed IoT lighting infrastructure can add major benefits and advantages to city management. Now, so next use case will learn the smart parking system and how smart parking is going to work and what will be the architecture of that. And next we'll study smart traffic control system and what is its architecture. Okay, like that we'll take some use case examples, then we'll learn. Okay, so today I will wind up the class. Thank you one and all. Have a nice day.